So we'll do basics in this course. Let's see how far we can go. We can start with the concept of a set of values that are the weights for every data point in our data set x1, x2, two-dimensional data set, which has a bunch of examples. Every example has a target value. To keep it simple, we can say it's binary. These are numeric values. A bunch of examples, and we want to estimate set of weights corresponding to each input, W1 for x1, W2 for x2, and these inputs will do some magic. These weights will give us they will project every input to a line. Now, it's going to be a linear combination of weights. You have weight 1 x1 plus weight 2 x2 plus, if you have 20 inputs, there will be 20 weights, and this linear combination or weighted sum is doing something. It is taking every input, multiplying with the corresponding weight vector, and we get something that is the projection, linear projection of inputs onto some linear. If it's just two-dimensional, it will be a line. If you have three-dimensional, it will be a plane, like a paper. Four-dimensional, we don't have a name or shape for that, but it will be linear. N-dimensional, linear space, linear thing. We cannot imagine it, but it will be linear because all inputs have the power 1. As long as the power is 1, it's linear transformation. When we change it from 1 to any other number other than 0, then it becomes non-linear. So this weighted sum is a bit magical in a way that it has interesting properties. Number one is, let's draw a 2D space that has origin 0, 0. And suppose our data is also zero-centered. So there are a bunch of values here and a bunch of values here. And they belong to two different classes, class dog and class circle. If you want to separate both classes, what is the simplest decision function you can make to separate both classes? Straight line. You can draw a line that is many possible lines between this space, infinite, but let's say this is our line. And we are going to call this class boundary. Because it discriminates class A from B, 1 from 0, male, female, fail, pass, whatever. This class boundary has the same shape. It's the linear combination of weights and inputs. But this is something that, it's a line, so line, we can write line in, so every point on line is equal to some multiplication of some weight with x1, some weight with x2. Let's say we have x1 here and x2 here. These are the weights. Once multiplied by values of x1 and x2 in sum, they are going to give us a decision. That decision is based on an interesting geometric property of a magical vector that is perpendicular to our decision boundary. So the angle between the vector W, which has two values, W0 and W1, or W, let's call it 1 and 2. The class boundary is perpendicular to this value. If we can somehow find a vector that once multiplied by any point on this decision boundary gives us 0, so the weighted sum that we have here, we can write it as W transpose X, or dot product of W and X. If it is 0, when the weighted sum is 0, that means your point, any point on this class boundary is going to form a vector, and that vector will have a relationship with our weight vector. And that relationship is they are perpendicular. How do we know that? Because multiplying W with that X is going to give us 0. That means this represents our solution. The weight vector represents our solution. We can say that when W transpose X is greater than 0, we are in this class. When W transpose X is less than 0, we are in this class. Whenever it is 0, we are on the class boundary. Make sense? Let's start again. So we are looking at a data set where every example is composed of some inputs represented by X. There may be M values, but to keep it simple and visualizable, we keep only 2 inputs and a label. This is our target variable. Target variable means that it encodes this data point belongs to which class. So how many classes we have here? 2 classes. So a binary classification problem. Is at hand, and we know from our weighted sum formulation that we are looking at linear solution. There may be a special type of problem where your classes are, your data points look like this. So you have 2 classes, triangle and circle. Can we use line to separate these points? Right? So we need a non-linear solution. Our class boundary will look like a circle. So there should be a term if it is x1 and x2. We need to square one or both of these to get a circle. When we have more than one power, more or less than 1, then our equation becomes non-linear. So this is a non-linear classification problem. We will close our eyes for this moment. We don't want to solve it for now. Only this kind of problem, where the classes or data points are linearly separable. Linear separability is our assumption. If it is the case, a simple solution could be W transpose X. Wherever W transpose X is 0, that X is on the class boundary. Now, where do we get this magical W? Once multiplied by X, it gives us the perfect class boundary. There could be a finite number of options, lines here, right? Which one is the one that perfectly separates both classes? How do we find that? So finding that W, finding these 2 values, has many different ways. The one that we want to talk about now is called Perceptron. Ever heard before this time? First time? Perceptron? Perceptron is about mid-60s, the first neural network idea. You have one unit that will take inputs, multiply them with W's, and decide based on the value. If your weighted sum is positive, you are in positive class. Weighted sum negative, you are in negative class. So this solution seems simple, right? No magic till now. The only question would be that you want to find this W. Well, how do we find? There is as long as the problem is linearly separate, there is a special vector W that can separate both classes. How to find that? So we don't have solution at hand. We start by assuming that W1 and W2 both are 0. So we will multiply this 0, 0 with first input. The output is going to be, when we put 0 here, output will be. We will compare that with the target. Is target 0? No. Then we need to change our W. So W1 will be changed as much as some special value alpha, I will explain what is it, multiplied by your, can I call it y hat? The estimate of y. Y actual value, ith value minus y hat. Now y hat multiplied by x1. And W2 will be W2 minus alpha yi minus y hat of ith example multiplied by x2. So this is our update rule. How do we update? We start by 0, 0. If this example is correctly classified, that means yi is equal to y hat, which makes them 0. So no update. If ith y is different from y hat, which is W transpose x, then we are going to change our W as much as the amount of mistake we made. We made this point is misclassified, right? This input is misclassified. So we will update W as much as the misclassified input. W2 as much as the misclassified input for corresponding variable. We keep doing this. If the problem is linearly separable, we update our weights maybe bunch of number of times, 10 times, 15 times, we don't know. But we keep updating them until we get all points perfectly separated. So W transpose X will work. Update rule, we will apply how many times? Now there is a new word coming. We have n examples, m features. In this algorithm, we go one data point at a time. Misclassified, update. Correctly classified, move on to the next. All data points fed into Perceptron once, it's going to be called an epoch. An epoch is for all training scenarios. Once passing all the inputs through the algorithm is one epoch. So you will, depending on the problem and the starting point, maybe you can start from 0.1, 0.9 randomly, or 0, 0. Depending on the starting point and the problem type, maybe 10, 15, 20 epochs, but every next epoch, you will make less number of mistakes. And then less, and then less, and you will end up. So imagine you start from here. 0, 0 is here, right? 0, 0 is actually vector right here, and some of the points, this is misclassified, so next vector will be here. The next one will be here, here, here. So we are trying out all, once we reach here, corresponding to this line, the vector will be the solution. W vector will be the solution vector. And you stop. You come out of your training loop, stop updating, and output system. Mechanism is called Perceptron. Now, this thing, weighted sum, a bit changed, and you can do nonlinear as well. We put more Perceptron units. Imagine your Perceptron is a unit here that takes 1, 2, 3, 4, m inputs. You apply, every connection has a weight, 1, 2, 3, Wm. You apply W transpose X, you check. If it is greater than 0, you say class is Less than 0, you say class is 0. That's all. You do. Now, this unit is good only for linearly separable problems. And only because of this capability, Perceptron caused a big hope in 60s for AI to be just like ChatGPT these days. But quickly people realized that it is good only for linear separable problems, and it cannot even separate XOR, right? With one line you cannot separate zeros from ones. So you need some function like this, non-linear function. So that caused Perceptron to go out of favor and lots of criticism. Early 70s, people saw what we call it AI winter. Now we are in spring. That's why class is full. But there was a winter when all funding evaporated because of this realization. But early 80s, then people, 90s. If you put multiple perceptrons in this layer and feed the inputs to all the perceptrons, then combine, then we call it multi-layer perceptron that can solve nonlinear problems, given that you pass this W transpose X through some nonlinear function like sigmoid or ReLU. You will test those somewhere down the road, but not for today. For today, we have only perceptron, basic understanding. You look at a problem, as many inputs you have, as many dimensions of the problems you have, and you need as many ways to solve that problem. In the context of expert systems, we will need this kind of trick or technique when we don't have an expert. So before today, we were going to an expert, asking questions, creating rules, and then, but sometimes we have tons of data, but no expert, or expert is very expensive to talk to. So we need these algorithms to extract. Now, Perceptron extracted this rule for us, right? W values are kind of a rule. Whenever you multiply that with any input, if the output is positive, class is positive. Output is negative, class is negative. It's a rule, but extract not given by human, learned, data-driven. Any questions? Easy, right? So I will give you some code to play with this, and in like 15 minutes from now, then we start our midterm. But before that, just go through this kind of toy solution of Perceptron and Python. So we go to ANN module, where we have module 7. Perceptron. There is a notebook, the Perceptron. You download it and play with it, run it. You will see we are just we have a for loop. We go to every data point one by one, apply W transpose X, check if it is positive. In the class is also positive. We move on to the next data point. If the output is positive but class is negative, we update. In a for loop, we run through the problem a couple of number of times, and that's all there is. Other than this, we got to form our groups for projects.